Hey, welcome to the next video in the Flappy Bird series. I'm Hugh Perkins. What we're going to do in this video is we're going to look at so in the previous video, we took this very colorful, beautiful image and we shrunk it to being gray and small, and that's beautiful, but smaller, maybe that would train faster in a convolutional neural network. What we're going to do in this video is we're going to stack several of these images up so that we have the current frame, previous frame, frame before that, ready to feed into a neural network. This will let the neural network detect when things are moving, which direction, and how fast. So let's go. Okay, so we've managed to convert this into decent sized pictures. What we need to do is we need to collect the previous frames. All right, so we're going to have frames. It's going to be a list, so we're just going to add the latest one to the list, stack the list up, add the latest one to the list, remove the older one from the start, so we should make it a decade, DQE, double-sided Q, and yeah, so frames L is going to be dec. It's from collections, but I can't remember. Anyway, so let's try from collections, import dec. There we go. We can get rid of it. Looks like we can get rid of pygame. Alright, so this is our frames.l. To start with, it's going to be empty. We should push some stuff for it. So we should decide how many previous frames. So, alright, so previous frames equal, let's store 2. Okay, so for I in range previous frames, we're just going to push some empty tensors in here. So frames L dot append torch dot, so we're just going to have like zeros, and so we know that these things are 36 by 64, image width equals 36, image height equals 64. Like ideally we would determine that automatically somehow, but that's kind of pain to do, so I'm just going to do it like this for now. Alright, and then we've got a screen buff T. So you know what we're going to here, we're going to do this unsqueeze, but afterwards we're going to immediately squeeze it. And then we don't have to do this bit here. Let's just check that works. Alright, so that runs. And let's just try opening one of these images. So temp, like 60. Okay, that looks fine. Right, so we've got this screen buff T. I guess we can put this down here so that it fits onto the screen. Right, so what we're going to do is frames L dot append and then the most recent screen buff. And then we're going to truncate it so that it's only like the most recent, like we've got our previous frames, right? Okay, so we're going to go from minus previous frames -1. This should truncate the frames, I think. Okay, so print len frames L, len frames L, and then we're going to stack these all up into a single tensor with the first dimension is going to be 3, which is the frames, like the second to last frame, the first frame, the second to last frame, and the next frame. So we'll stack these up into a tensor. So frames T equal torch.stack frames L, and we're going to do this on the first dimension. So if I print frames T dot size, it should be something like 3, whatever our size is, 336, 64. And just make that crash. Sequence index must be integer, not slice. What? Previous frames is an integer. you know, I'm just going to do stupidly, well, frames L, well, len frames L is greater than previous frames plus 1. We're just going to pop left, so frames L dot pop left. All right, there we go. All right, so where are we? So, all right, so we've got tensor of 3. Then torch.stack must be a tuple of tensors, not a collection of decades. So we should probably just make this a list. This is going to be easier, but anyway, I'm not going to make that list. So make this a list. So obviously it's copying it anyway, so it's a complete waste of time to use a decade here. All right, so we've got three images. Like the first 2 are empty, just zeros for now, but we're going to fill those in each time. And then, yeah, so this is ready to feed into a convolutional neural network. All right, so we've got our frames that we're going to give to the network. So at this point, this frames T is 3, what was it? 36, 64. 3, 36, 64. Cool. Hey, so that's it for this video. In the next video, what we're going to do is we're going to look at taking this stack of images and pass that through, well, we're going to design a neural network that we can pass this stack of images through. So hopefully I'll see you there.